Hey guys, it's me again. Welcome back. It is our last session together before spring break. So we're going to work on our first section of probability and we will continue it after spring break. So everybody has their I and B out, and I would like you to please head it probability. And we'll do section 1. Okay, probability section 1. We talked a little bit about probability last time. I'm going to formalize it a little bit more this time. So here's some notation that you're going to need to be aware of. You'll see something like P parenthesis event. That means simply the probability of an event. It's not always going to say event, obviously. It could be the probability of heads, or the probability of tails, or the probability of a red queen. But it's going to be the probability of some event. And we're going to find out the probability, so how likely it is to occur. When we're doing these problems, we need to keep track of our outcomes. So outcome. And that is the result of a single event. Result of a single event. Okay. Now, there are lots of different kinds of events. We can take a look at one event at a time. And so let's say we're talking about flipping a coin. That could turn out to be heads or tails. So all the possible outcomes make up something called the sample space. So the sample space is all possible outcomes. All right. And the event, here's my clock again. It's 7:15. The event is any of the outcomes. I can spell outcome. The event is any outcome. Okay, so here are some vocab words that we're going to use throughout all of our sections in probability. So let's talk about theoretical probability. That sounds very fancy. Theoretical probability. All right, so theoretical probability, it finds the probability of an event, and it's equal to the number of favorable outcomes divided by the number of possible outcomes. So this is what we worked with in the last section when we were talking about probability. You were doing theoretical probability. So let's look at an example. What is the probability of rolling an even number on a die? And we'll say it's a standard 6-sided die. Probably an even number on a die. So let's talk about the number of favorable outcomes. So on a die, how many of the numbers are even? Well, we have 2, 4, and 6. So that was 3 of them. So 3 of them are favorable out of how many outcomes are there possible? 1, 2, 3, 4, 5, 6. So there's 6. So our theoretical probability is 1/2, or you could write it as 0.5, or you can write it as 50%. You need to be comfortable with all of those ways of looking at it: fraction, decimal, percent. So the probability of any event is going to take on a value, and its value will be between 0 and 1. So the probability of an event ranges from 0 to 1. So what is the probability that my cat brushed his teeth today? 0%. So you could have 0 probability. What is the probability that I'm eating pasta in Italy? 100%. So you can have 0 and 100 as your, and 0 and 1 as your probabilities. That's fine. Or 0% and 100%. All right, so let's talk about the probability of an event not happening. So the probability of an event not happening is, well, what's the probability that the event will or will not happen? There's a 100% chance that it will or will not happen, right? That's our total. So we could say the probability of an event not happening is 1 minus the probability that it happened. Or we could say the probability of an event happening plus the probability of an event not happening is 1, or 100%. So let's think of an example. The probability that Aiden is talking and the probability that Aiden is not talking. If we added those two together, we get 1. Now you probably have heard about things like the odds of something happening. So let's talk about that really quick. The odds of something happening. That is the favorable over the unfavorable. Or the event happening divided by the event not happening. Okay, the last thing we need to talk about is experimental probability. Experimental probability. So this is what the probability you come up with when you're actually doing an experiment. So you're actually flipping the coin to see if you get heads or tails. And so the experimental probability is simply the number of times an event occurs divided by the number of times the experiment is done. Okay, so those are our I and B notes. Go ahead and pull out your packet that Dr. Dixon either gave you or will give you, and we're going to go over the examples. You might need to pause right now to get everybody caught up to speed. But this is our examples page. Everybody should have one. And we'll work through these 5 examples together. All right. A bowl contains 12 slips of paper, each with a different name of a month. Find the theoretical probability that a slip selected at random from the bowl has a name of a month that starts with the letter J. So remember, it's favorable over total. So favorable over total. Well, the total is super easy, right? How many months are there? 12 months. Okay, Favorable, let's figure this out. We have January, February, March, April, May, June, July, August, September, October, November, December. So 3 favorable, January, June, July, over 12 total. Please always reduce your fractions. So we have 3 goes into 3 once, 3 goes into 12 4 times. So it's a 1/4 probability, which is also 0.25 or 25%. All right, finding the complement of an event. Here we go. This is the probability it's not happening. So on a popular television game show, a contestant must choose one of 5 envelopes. One envelope contains the grand prize, a car. Find the probability of not choosing the car. Well, let's find the probability of choosing the car. So they choose one of 5, and one envelope has the grand prize, which is a car. So getting the car is 1 out of 5. So the probability of not getting the car would be 1 minus 1 out of 5. And you guys are really good with your fractions at this point, so you would know that it's a 4 out of 5 chance. Okay, now we're finding the odds. So remember, odds are favorable over unfavorable. So find the odds in favor of the spinner landing on a number greater than or equal to 6. So greater than or equal to 6. There's a 6, a 7, and 8. So the favorable, there's 3 of those. Unfavorable, there's 1, 2, 3, 4, 5 of those. So it's 3 to 5 odds that it will land on a number greater than or equal to 6. Okay, finding experimental probability. So this is the number of times the event occurs divided by the number of times the experiment is done. After receiving complaints, a skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer found no defects in 992 skateboards. What is the probability that a skateboard selected at random had no defect? Write the probability as a %. Okay, here we go. What is the probability that at random has no defect? So we have the number of times that the event occurs. So the no defects occurred 992 times. The number of times the experiment was done was 1,000. And so now we need to write it as a %. So 992 divided by 1,000. Well, if I put this over a 100, I'll have a %, right? So I can move my decimal over and move my decimal over. So that's 99.2 out of 100. And as a %, that's what? 99.2%. Okay, using experimental probability. So the same manufacturer has 8,976 skateboards in its warehouse. If the probability that a skateboard has no defect is 992%, phew, glad we got that right, predict how many skateboards are likely to have no defect. So we have 99.2% that will have no defect. So 99.2 out of 100 will have no defect. And if we have a total of 8,976 skateboards, what is 99.2% of that? Oh boy, looks like we're going to need a calculator because I don't know that I can do some of this multiplication. Cross multiply. 100x equals 99.2 times 8,976. All right, and then we'll divide by 100. Divide by 100. So x equals a number. I'm sorry, I don't have my calculator with me. But you all can figure that out. Maybe Dr. Dixon can do it with you. Alrighty guys, that's our last example. You can work on the rest of the packet for homework.